Okay, so the learning intentions for this class was to develop the formula for the surface area of a cylinder, and I've differentiated the success criteria into applying the formula or the strategy once established, score at least 2 out of 3 in this question if it was asked on a test, and understand how the formula would change in different circumstances. Um, so, why is this a rich task? I feel it's a rich task because the students, when they went into this class, they didn't have a strategy to find the surface area of a cylinder. They had done the surface area of prisms, they'd done the area and the perimeter of a circle, but they hadn't looked at the surface area of a cylinder. The success criteria, the second one especially, scored 2 out of 3 in the test, and here's the rationale for that. A lot of students in this class still struggle to begin problems when they are not 100% sure of the solution. And this is what the second success criteria is really about, having the students make a start to the problem. As the HSC moves more and more that way with 4-mark and 5-mark questions, students will have to be able to do this, make a start when they're not sure of where that question is going to go. So that was the philosophy of why that second success criteria was there. As I said, it was a rich task because the students weren't sure about how to do it. And that second success criteria is really about that metacognition. It's about, this is how we do maths. This is what we have to do. We have to make a start with questions. We have to think about the question. We have to set up that strategy. So that was why that was an important situation. And also teaching students explicitly about how things are marked in the HSC, how things are marked in Year 10 tests. This would be aimed at a Year 9 or Stage 5 class, 5.2 or 5.3. So this was my introductory task. Which of these nets would make a cube? And it was just those 5 nets. And then the second part, and this was a bit of summary of what we've already done, and draw the net of a cylinder, which obviously will become extremely important with the learning intention of today's lesson. In terms of the first pedagogical move I guess I made here was voting. I love students voting, especially for these last 3. Would they make a cube or not? The fact that voting and asking students to make that commitment to one, would this third one make a net, would make a cube, it automatically gives them wait time because they have to think about it. I don't want an answer straight away. It's emphasizing to these students that this is a hard question and I want you to think about it. And so I think that this whole idea of voting is really important. And the fact that they've made a determination and they've said, no, I'm voting for yes, it just puts a little bit more of skin in the game, a bit more of commitment to your answer, to justify your answer. And then I had just nets made up already with post-it notes. Basically taped together. It was very, very quick and easy, so they could be folded up. The student responses. This was the student responses to the nets of a cylinder, and obviously there should be another one here. These were the 3 nets of a cylinder that basically all the students drew, and the question was which was the best and why. We didn't talk about the circumference of a circle here. It was just which is the best and why, and most of the students talked about this one. The words they used was, this one wouldn't wrap around, the rectangle here wouldn't wrap around enough, and this one would wrap around too much. Again, so this task explicitly links to the learning intention because this is the drawing that they're going to be using in this the task. So this was the main task. Find the surface area of the cylinder below, showing or working. And I emphasise the showing or working, and that was for a campfire or a fishbowl later on that was going to happen. If they needed a hint, an enabling prompt, these were the hints that I verbally said. Look, if you're having trouble, a picture may help. Remember the introductory task, linking it back. And then I also gave them the area of a circle and the area of a rectangle. So these were the student responses I've got, and this was when the 5 practices came into. Um, I've got 3 student responses. The first one, this was the first one, and by monitoring the students, I then sequenced these in this order for a specific reason. So I've selected this one. Um, it emphasises the fact that, yep, this person, they know the area of a circle is pi r squared. They know that the second area is pi r squared. They just don't know that rectangle. And they've used 12 at 12 times 20. Perfect. And then bringing that back. Okay, let's have a look at what this would have scored in a test. Okay, so there's 1 mark for finding the area of a circle. They've got this wrong. They knew they had it wrong, but they've written something. They've got this as well, and then they've added it up. So they've got a mark for this. They've got a mark for knowing that they've got to add them all up. What they've lost is 1 mark here. So have they fulfilled that second success criteria? They have scored 2 out of 3. Even though they didn't know how to do the question, even though they knew they were wrong, they still scored 2 out of 3, which is excellent. That's what we're aiming for. So I've used the 5 practices. I've taken a picture of the student's work. I've put it up. I really like to ask another student to explain this person. Can people see what this person's done? So if Michelle has given me this response, I will not get Michelle to answer that. I will see if somebody else can. And the other thing that that does is make sure their working is good. And you can see the work in here is very, very good. The next person, I couldn't resist putting this one up. I thought it was beautiful, even though the student didn't really want me to put it up because, again, she knew she was wrong. She had the area of a circle is pi r squared, and then for the rectangle here, she used 3 times 12 is 20. And when we did the fishbowl, when we did the campfire, and I got her to explain why did you use 3 times 12, and her words were, just as in the introductory task, I think about 3 of them would wrap around. But she felt she was still wrong. She said, I'm not really sure. I don't think it's right, but I think about 3 of them would wrap around. So here's where you bring in the need to knows. Okay, so what do we really need? We all agree that you can find the area of this. We all agree you can find the area of this. We all agree that you've got to add them up in the long run. So that's what we know. What do we need to know? What is the same and what is the different about these? What we need to know is this length here. So need to know, there's another metacognitive activity there, that this is what we want you to be thinking about when you're doing questions. Make a start. Once you get stuck, what do I need to know? I need to know this length here. Now, this person's got 3 times 12, but that's that need to know, is that pedagogical move. And this was the last one. While she was explaining it, I had an A3 piece of paper as a concrete response, and obviously, if that was the best response, I often will try to get her to explain it. I had to ask her to write this down, this 2 pi r. She knew it was 2 pi r, but she hadn't emphasised that enough, so I asked her to write that down before I put it on. And then we also talked about how close the other person was. The other person had 3 times 12. Well, this is 3.14 times 12 because you get twice the radius. So it's that idea of how close were you? You knew you were wrong, but you were very, very close. You had the right terminology. You had the right thinking. But as I said, that was using the 5 practices, using the students' work, having other kids explain their answers, explain their working, which is a really good tactic. The consolidating task, now we know how to do it. Through the explanation of the students' work, I want you to have a go at these 3 questions. That was really the first success criteria. This is when we get into the first success criteria. So we've almost launched at transfer level. launched a fairly deep understanding, brought it back to a lower understanding, this surface level, use success criteria 2, and then we've come back to this success criteria 1 in the consolidating task, making sure everybody has a basic understanding of how the formula works, or how the strategy works, because I really didn't look at the formula, I looked at the strategy. These were the extending prompts, or their extending tasks. So, and the question was, what steps would you use to find the surface area of these shapes? So I didn't want the answer, I wanted the steps. Now the first one was a trash can. So what is the implications of it being a trash can? The next was a section of pipe, and we want the surface area of that section of pipe. And the last one was a cylinder that is cut in half. So by doing these questions, which aren't really that much more difficult, but you really need to understand the formula and where things are going from. So this one, and this is really, we're aiming at success criteria 3 here. We're really looking at, okay, this is only the bottom plus the rectangle. This would only be the rectangle, so it's only the circumference of the circle times the height. This one, you've got to find that rectangle, and then so it's really pushing that metacognition. And the way I would have done that in these questions is some paired thinking. So get students to work together, and then look at think alouds. Okay, so what are you thinking? Can somebody explain to me? We didn't want numbers. That's what it is. What steps would you use? So I'm specifically saying I don't want numbers. I want you to explain how you would find the surface area of the trash can, the surface area of this, the surface area of that. And obviously, you're looking at your better students to do this one. The first two would be, you would hope most of your class can get. This last one, it's that getting the students to explain their thinking is the important part to this. So, and again, you're honing in on that metacognition. What were your steps? What were you thinking? Why did you do that? Well, it was a half a circle on the front and the back, so I need a half a circle. I can see that last one is the area of a rectangle, and then the last little bit is that half rectangle, so I only need half. And having students explain that, and having students explain not just once, but going to somebody else. Is that how you did it? Can you explain it to me as well? Because I'm not 100% sure everyone understood that first person's explanation. Can you explain it to me as well? And emphasizing that, those think alouds, that metacognition. How are students thinking? Okay, thanks.